Now we are going to actually take a look at some of these. So looking at these four graphs, you should be able to look at them and identify what the parent function or what family function these come from. Right? So looking at A, that has a V, so that should be a sign that is an absolute value. All right, for part B, it's a horizontal line. All right, so what type of function is a horizontal line? Well, that's from the constant family. 1A, down in the bottom left there, is a parabola. So that is a type of quadratic. And 1B is a straight line, so that is a linear equation. So it is from the linear family. So now we're going to look at and kind of play around with what happens when we actually graph these functions. So we have the absolute value of x. Well, first and foremost, I want you to try to identify the function. If we graph the absolute value, you need to know your parent. The absolute value of -2 is 2, the absolute value of 1, 0, 1, 2, right? So your basic absolute value function is going to look like this. Well, if you graph the absolute value of if I plug in -2, -1, 1, well, if I plug in -3, 1, that's 1, 2, 3, 4, 5. And once again, I don't have that V shape. I needed to put so that's going to be -3. That's going to be what does this look like graphically? I'm at -4, 1, -3, 0. This look something like this. And you can see here that to go from the blue graph, my parent function, to the red graph, I have moved left 3 units. So you'll hear me a lot say talk about inside the math and outside the math. If it's inside the absolute value, if it's inside what is being squared, that's what I refer to as inside the math. And that means it is going to affect your x values, right? And what that means, you're either going to move left or right. Now, the thing is with x's is they live in what I refer to as opposite world. So when I look at the absolute value of x plus 3, well, I think, I'm adding 3. I should be moving right. But x's, that's not the case. It actually moved it left 3 units. And to reason that out, and the way to kind of think about it is your y values, your range has stayed the same, right? So I still have a 0, 0. My y values have stayed the same, or 0 y value and so forth. So in order to get to that same y value, if I added 3 in my equation, that means I had to have started 3 units to the left to end up at that same spot, right? So you just need to remember with x's, it's opposite world. So if it's a plus 3, it means you're moving left 3. If it was the absolute value of x minus 3, well, then that would be the same thing as moving right 3, right? Now, when we look at 2b, this is what I refer to as outside of the math. If it was inside of the math, it would be x minus 4 squared. But it is not included in the squaring. So since it's not included in the squaring, that means that it affects your y's and not your x's. So first, let's talk about our parent function. And our parent function is x. I plug in -2 or 2. Well, -2 squared is 4. -1 squared is 1, 0, 1, and 4. And yes, you will need to know these t-charts for your parent functions. So graphing those, It's going to be a 3. You can draw your parabola and make it look like a parabola and not an absolute value function. All right? So -4, well, what is that? What that means is it's going to move your y value. All right? So we refer to this, let's see here, -2, -1, 0, 1, 2. If I plug in and square this, well, it's going to be 4, and then I'm going to subtract 4. So I'm actually going to be at 0 here. If I plug in -1 squared, I get 1 minus 4, I'm at -3. If I plug in 0, 0 squared minus 4 is -4, -3, and 0. So what this is going to look like is I'm going to be like this. And what happens is every point that I had in green is going to be moved down 4 units. So I took my original parent function x squared and I shifted it down 4 units. So what this looks like here, for 2a, we would label this an x translation of -3. We move the left 3. So this would be an x translation of -3. For 2b, this affected our y. It moved it down 4 units. So we would label this a y translation of -4. So we're calling for transformations, or translations rather. If it's inside the math, it moves it left or right. If it's outside the math, it moves it up or down. All right, so we're going to take a break there so that I don't run out of time to do these next two. So move on to the next video.